Section 1.7, function notation. Please write down the essential question. How can I write and evaluate functions? So when we look at the notes here, we have a function f of x equals 5x plus 3. When we're talking about input and output, the input value are our x values. The output value are f of x, which is also y. And it means f of x equals 5 times x plus 3. It is not 5 times x. That's what this caution says. F of x is not f times x or f multiplied by x. F of x means the value of f at x. So f of 1 represents the value of f when x is equal to 1. So basically is over here, when x is equal to 1, the y value is going to be 5 times 1, which is 5, plus 3 is 8. That's what that represents. In the notation f of x, f is the name of the function. The output f of x of a function is called the dependent variable because it depends on the input value of the function. The input x is called the independent variable. When a function is graphed, the independent variable is graphed on the horizontal axis, and the dependent variable is graphed on the vertical axis. And when we're talking about, I want to write something as an ordered pair. It's not what I wanted to do. Let's get my pen here. So we have our input, we have our output. Another way to write it is x, f of x. So when we talk about y, sometimes we're going to call it y, sometimes we're going to call it f of x. Here's an example of what I talked about on the last screen regarding the dependent variable, which is like our y variable, and the independent variable. In this case, we're using t. It's like the x we're talking about. Independent variable is on the x-axis. The dependent variable is the y-axis. So let's do example 1. For each function, for this function, evaluate. So they want us to find what is the value of the function when x is equal to 0. So basically what that means is I'm going to take 8 plus 4, and in place of x, I'm going to plug in 0. Well, that's just 8 plus 0, which is 8. Let's try f of 1/2. 8 plus 4 times 1/2. Well, that's just 8 plus 4. Half of 4 is 2, which is 10. Let's try, scroll down, f of -2. 8 plus 4 times -2. Well, that's just 8. 4 times -2 is -8. That is 0. So each of these inputs, 0, 1/2, and -2, generated a different output, 8, 10, and 0. Example 2 we're going to do in class, and now we're going to jump to example 3. Now we're given a graph, and we're asked to find f of 0, f of 1/2, and f of -2. This time, instead of plugging the x's into the function, we're going to look at the graph. So when x is equal to 0, on the x-axis, that's right here, I'm going to go up until I hit the function, and that's right here. Well, the value, the y value right there is 3. At 1/2, when x is 1/2, the y value is 0. When x is -2, I have to go up, the y value is 4. So again, for each of these inputs, we have an output, which is our y value. And we found those by looking at the graph. Up here, find the following values for the function. We are going to do those in class. I'm now going to scroll down and we're going to talk about discrete functions and continuous functions. On a discrete function, there are no points connected. There are breaks. On a continuous function, there are no breaks in the graph. So this is discrete because I'm not connecting the dots. And when I put the dots on, I put the dot on, I take my pen off, I put another dot on, take my pen off. The points are not connected, and there are breaks in the graph. Continuous is a continuous line. I start here and I draw my line. I never pick up my pen. That is continuous. No breaks in the graph. Example 4, it's asking us to graph the function f of x equals 3x minus 1. So what we're going to do is we're going to make a table. And usually what I say when we're making a table to graph a function, we pick about 3 x values. And honestly, it doesn't matter what x value you pick. Every x value is going to be associated with a y value. However, I like to pick x values that are easy to plug into my function. So a lot of times I'll pick a negative number. So -1, 0, and 1. Now, let's plug those in. So if I plug -1 in here, 3 times -1 is -3. -3 minus 1 is -4. So that is our y value. Now let's plug in 0. 3 times 0, go. So if 3 times 0 is 0, minus 1, that's -1. And plug in 1 for x. 3 times 1 is 3, minus 1 is 2. What we have just generated are 3 ordered pairs. -1, -4, 0, -1, 1, 2. Let's plot them. -1, so you start, when you graph points, you start at 0, 0. I'm going to go left 1 and down 4. 1, 2, 3, 4. Here, x is 0, so I'm not going right or left, but I'm going down 1. On 1, 2, I'm going to the right 1 and up 2. This is a function which is going to generate a continuous graph. So now let's see if I can connect them here. I always struggle a little bit with this. Let's see, pretty good. Okay. There. There we go. That is a continuous graph. This function generated a line. On example 5, it's different. I'm not given a function as an equation. I'm given a relation, meaning we're mapping 3 to 2, generating an ordered pair. We're mapping 5 to 6. We're mapping 7 to 10, and we're mapping 9 to 10. This is going to be discrete. We did not have an equation. Instead, we have different points plotted on a graph. Start at 0, 0, go over 3, up 2. There's my first dot. Go over 5, 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6. Go over 7, 1, 2, 3, 4, 5, 6, 7, up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, if that's 7, 10, and we went over 9, up 10, that'd be 9, 10. This is discrete. I do not connect the dots because the only points that are a part of this function are the distinct separate points. Whereas up here, I have an equation that's a function, meaning there is an infinite number of x values that will work to create this graph. That's why it's called continuous. Example 6 is a word problem. A carnival charges a $5 entrance fee and $2 per ride. Per, a lot of times you're going to see on word problems is going to mean we're going to be multiplying. Write a function to represent the total cost after taking a certain number of rides. Well, let's call R our number of rides. Let's call C our total cost. So a function has to be something like this. If C is like our Y value, you have to write it C of R, because that's like your X value, your input. A carnival charges a $5 entrance fee and plus $2 per ride. And there is our function. Well, let's scroll down. So what is the cost if you go on 8 rides? Well, that's telling me that R is equal to 8. So we are really using this. We are going to use the function that we have above. And we're going to plug in 8 for R. 5 plus 16 is 21. So what is the cost if you go on 8 rides? You're going to pay $21. Example 7, we're going to do in class. And these are the video questions. I'm going to scroll down. So what you should do is on number 1, we're going to graph the function. You're basically going to pick, is it A, B, C, or D, the graph of this function. And then you're going to do the word problem. You're going to write a function to represent the total cost after buying a certain number of rides. Pause the video and answer those 2 video questions in your notes.